Hello there, and welcome back. What we have here is the equation of a hyperbola, x minus 1 squared over 25 minus y squared over 11 equals 1. And we're going to, by looking at this equation, we're going to find all of the graphical aspects of this hyperbola, including the center, the vertices, the foci, the asymptotes, and the eccentricity. So by looking at the equation, the coefficient of the x squared term is positive, which means that the transverse axis is horizontal, meaning that the center, vertices, and foci are all along a horizontal axis. So I'm going to draw a horizontal axis, just like that. Now looking at the squared terms in the numerator, we have x minus 1 squared and y squared. That indicates that the center of the hyperbola is at the point 1, 0. X minus 1 corresponds to x minus h, and y minus 0 corresponds to y minus k. So the center I'm going to label here at 1, 0. Now the denominator of the x squared term is 25, which means that a squared is 25 and b squared is 11. So that means that a is equal to 5, and that means that the vertices are each 5 units away from the center. So 5 units to the left of negative 1, 0 is negative 4, 0, and 5 units to the right of 1, 0 is 6, 0. So there we have that. So our vertices are negative 4, 0 and 6, 0. Now to find the foci, remember that c squared, c being the distance from the center to a focus, is equal to a squared plus b squared. So we already know that a squared is 25, and we know that b squared is 11, which means c squared equals 36, which means c, the distance from the center to a focus, is 6 units. So it's going to switch colors up here. That means that 6 units to the right of 1, 0 is 7, 0, and 6 units to the left of 1, 0 is negative 5, 0. So our foci are negative 5, 0 and 7, 0. Okay, so there's all of the points that we need to find. Now remember, hyperbolas have asymptotes that pass through the center and have a slope determined by a and b. So in this case, the slopes are, well, is it going to be a over b or b over a? That's what we want to know. So since the a equals 5 is with the x squared term, and the b equals square root 11 is with the y term, the slopes of our asymptotes, I'm just going to write that here, asymptotes, the slopes are plus or minus b over a, the y coefficient over the x coefficient. So that means square root of 11 over 5. And we know that they pass through or contain the center, which is 1, 0. So our equations are y minus 0 equals plus or minus square root 11 fifths times x minus 1. And that basically boils down to y equals plus or minus square root of 11 fifths times x minus 1. So I'm going to write that in the blank up here just to kind of have it in a nice condensed form. Now if we wanted to graph these separately, naturally we would have to expand each one. So just to show how that works out, we have y equals negative square root 11 over 5, x minus 1, and y equals positive square root 11 over 5 times x minus 1. And we'll just distribute at this point. So we have y equals negative root 11 over 5, x plus root 11 over 5, and y equals root 11 over 5x minus root 11 over 5. So there's our asymptotes. And now eccentricity Remember, the eccentricity of a hyperbola or an ellipse basically tells you how elongated the curve looks. Eccentricity. And it is the ratio of the distance from center to focus to the distance from center to vertex. And since the foci are further apart from the center than the vertices are, we expect the eccentricity of a hyperbola to be greater than 1. Well, in this case, C is 6 and A is 5. So you could either report 6 over 5 or 1.2. That just emphasizes that the eccentricity is greater than 1. And there we have all of the graphical aspects of our hyperbola.